and activate protection sensors against overfilling. A second pipe, known as a vapor recovery pipe, absorbs emitted vapors to prevent them from dispersing into the atmosphere. About 4 million liters of gasoline is transported to gas stations every day. After pouring the gasoline into large tanks, it's ready for consumption. The next time you fill up your tank and think about the high fuel costs, take a moment to acknowledge the sweat and toil of the laborers and oil producers who make it all happen. If you want to know how sheep's wool is converted into clothes, watch the video on your screen. Like the video if you have enjoyed it and share it with your friends. Also, subscribe to this channel by activating notifications to keep learning. Thank you for watching.
Okay, good morning everyone. So we're now with topic on the application of chemistry with environmental concepts. This is focusing on environmental chemistry. So Chem is actually the field of chemistry that focuses on the study of the sources, reactions, the fate of pollutants. Let's say the resources. Now, because of existing environmental problems, many scientists, including engineers, have been interested with studying environmental problems. So, if you would ask, our biosphere actually is composed of different components. So, we have here the composition of our planet. We have the biosphere as a whole, which includes the atmosphere, the crust, the vegetation, animals, rocks, and soil. So part of the continental crust is the region known as lithosphere. So lithos coming from the, I think that's a Greek word for soil. Then you have here the composition, like the lower mantle, you have the core. So the inner core is made up of molten components of an iron composite materials that causes the observed magnetic field of the earth. That is because of the paramagnetic properties of an iron composite materials in the molten state inside a core. And of course, we have here the hydrosphere. So if you talk about hydrosphere, this is the region of the fresh water, including the salt water. So we call it hydrosphere. Then of course, the atmosphere with the different layers of the atmosphere. So each of these components like lithosphere, hydrosphere, atmosphere can serve as environmental sink to different pollutants. So, I mean to say that the pollutants we generate either from the air can interact with the hydrosphere. At the same time, it can also interact with the lithosphere. So, these interactions, including the fate of these pollutants and the technologies used either to mitigate the measures in terms of the effects of these pollutants, is the scope of environmental chemistry. So to start with, let's try to look at what sustains life on Earth. So Earth actually is a unique planet because it can sustain life, and part of this force that sustains life on Earth includes the solar energy. So we have, of course, the primary source of energy is coming from the sun, and which is the driving force behind the cycling of elements in nature. So we have free supply of these elements, including carbon, phosphorus, nitrogen, water, and oxygen. So water actually, if you talk about water cycle, some books would refer that as hydrologic cycle. So the water cycle is more of physical transformation from the different states of water, from solid, liquid, and vapor state. Then of course we have nitrogen, we have oxygen, carbon, and phosphorus. So in general, these cycles are also known as biogeochemical cycles in the sense that they can interact with the atmosphere, with the hydrosphere, and the lithosphere. So part of this energy coming from the sun is responsible for a natural phenomenon which can sustain life on Earth. We call this one as the greenhouse effect. So the greenhouse effect actually is this one. You have here an incoming solar radiation in the form of UV, and then we have here the different layers of the atmosphere. So to start with, the lower troposphere, lower stratosphere is the ozone. So ozone actually it's one form of oxygen. We call that as an allotrope of oxygen, and the ozone there is responsible for filtering the harmful UV radiation from reaching the lower atmosphere of the Earth in the troposphere. So UV is a highly ionizing form of radiation which can cause skin cancer, for example, and other health effects. So that's why the role of the ozone here in the lower stratosphere is very important. Now, this decomposition of ozone into diatomic oxygen and the free radical oxygen is in steady state with the Chapman cycle. I mean to say that this decomposition and formation of ozone is regulated in equilibrium process. But because of human activities, we introduce some of the chemicals that accelerate the breakdown of ozone than it is being formed. So that creates a problem. So apart from this, because of the unique atmosphere of gases present in our troposphere, we have what we call as greenhouse gases in the form of methane. We have carbon dioxide. There is water vapor. So these gases makes the Earth's temperature suitable for life to exist. So it warms up our atmosphere just enough to support and protect life. So this is the greenhouse effect. So similar to a greenhouse, if you have seen one, it is housing for plants, especially for countries with winter. They have greenhouse gases to, of course, protect the plants from extreme temperatures in the winter. So they use the greenhouse gas as protection for, let's say, if you want to maintain the temperature of the plants to temperate conditions, then you need to have a greenhouse, especially during winter. And for this reason, because of if you look at the diagram here, majority of the solar radiation is absorbed by the ozone that is, of course, filtered, and then what reaches in the lower troposphere is in the form of visible and infrared radiation. So this form of radiation actually causes thermal vibrations with the chemical bonds between hydrogen and oxygen molecules in water, carbon and oxygen bonds between carbon dioxide, and they absorb the heat, and this would cause thermal radiation. So I mean to say that this energy is re-radiated in the form of thermal energy, which causes warming. And the rest of this is actually radiated back to the atmosphere. Let's say 66%. So this is what we call as the greenhouse effect. So if you take a look now at the different composition of the gases in our atmosphere, but before that, based on the principles of thermodynamics and the one-way flow of energy in the ecosystem, we see here that as the energy coming from the sun is absorbed by the producers such as phytoplanktons and the plants, then as this one goes up in the tropic level from the producers going up to the tertiary consumers, the amount of available energy here decreases as seen in this diagram. So I mean to say that if we try to match this one with the type of food that we eat, then we can apparently say that the energy we get from from vegetables, for example, if you talk about vegan diet, for example, then we get more energy than from consumption of secondary consumers. Let's say in the form of different kinds of meat, let's say beef, you have your pork, chicken, then the amount of available energy decreases such that most of the energy available for tertiary consumers is lost to the surroundings in the form of heat. That is because of the second law of thermodynamics. So from the first law of thermodynamics, we convert the chemical energy stored in the food that we eat into different forms of energy that our body uses in the form of, let's say, ATP that the cells make up for cellular productivity. So that is based on the laws of thermodynamics. So that is a one-way flow of energy. So going now into our atmosphere, we see here the different layers or composition. So we have here in the just above our air is the troposphere. This is where most of the greenhouse gases are found, including your water vapor, carbon dioxide, and your nitrogen and nitrous oxides. So the rest of the gases, including your nitrogen, your oxygen, causes a natural display of colors also. And then if we go up here from the troposphere, we go to the stratosphere, we have mesosphere and thermosphere. Now the variation of composition here in terms of the different chemical species present in the different layers can cause natural phenomena to exhibit, especially in the thermosphere region, where this one contains ionized form of gaseous particles coming from, of course, the solar radiation. So if you try to consider this natural phenomenon, then we can see that this one is actually a display of colors in the northern hemisphere. If you have seen, let's say, footages of this display of colors, you try to check on this.
We all know the aurora borealis are a spectacular display happening above, but do you really know what causes it? What is the aurora borealis?
When we watch that dazzling display of light, it's actually telling us a story. It's a story that began on the sun, traveled all the way to Earth, had a series of interactions in the magnetic field, and led to this beautiful display overhead.
The aurora borealis are caused by particles, electrons and protons, blasted out from the sun in all directions and colliding with gases in the Earth's atmosphere. Those particles travel 150 million kilometers from the sun to reach Earth. That can take from 2 to 4 days. That flow of particles is called the solar wind.
A lot of particles, when they reach the magnetic field, are deflected away into space, but some become trapped in the magnetic field. And what's going on is that there's this little spark that occurs, this release of energy that we see in the form of light. And so now imagine that overhead there are billions of these tiny little sparks going on. And the sequence of light, these little flashes of light, are what we see and call aurora. So if you're living in northern Canada or northern Scandinavia, northern Russia, around the North Magnetic Pole, seeing is this waterfall of particles that are following a magnetic field line into Earth's upper atmosphere.
So, why are they different colors? The Earth's atmosphere is made up of nitrogen, oxygen, and other gases, commonly known as air. The colors of the aurora depends on the gas molecules that the particles are mixing with. So green, the most common color of aurora, is a charged particle mixing with oxygen. Blue is when they mix with nitrogen.
Generally along the lower edge we see a really intense, very vibrant purple color. That's an indication of particles interacting with nitrogen.
Astronomer and physicist Galileo actually coined the term aurora borealis in 1619. It was after Aurora, the Roman goddess of morning. He mistakenly thought that the auroras were due to sunlight reflecting from the atmosphere, according to NASA, though indigenous northerners have oral traditions about the lights that go back generations. How high up are the auroras? Aurora are between 100 and 500 kilometers above the surface of the Earth. How high is that? The International Space Station orbits the Earth at about 400 kilometers above the surface. Astronauts on the space station often get a side view of the aurora.
that's still cool too, because the side view of an aurora can give you an unbelievable show. It shows you that how tall an aurora can be.
Saturn and Jupiter also have beautiful auroras, even more powerful than Earth. There is a lot of mystery around the aurora, though. Scientists are always looking at new missions to better understand the relationship between the Sun and the Earth and forecasting auroras and space weather. Modern day technology, like cell phones, also depend on that research since satellites can be affected by the solar wind. So, why are aurora more visible in the north? Well, most auroras occur in a band called the auroral oval. That's a huge ring of aurora above the Earth's north and south magnetic poles. The northern lights we see are just a small section of the auroral oval. Places like Alaska, Greenland, Scandinavia, and northern Canada are the perfect zone because they're close to the auroral oval. If you're at high latitudes anywhere on the planet, chances are every single night there is auroral activity overhead. When there is active space weather, it can push the auroral oval like an elastic band further south. That's when people right across Canada and even the United States can see the aurora. And let's not forget the southern lights. People living near the South Pole can see the aurora borealis' cousin, Aurora australis.
It's really, truly a scientific wonder. And there's a lot that we still don't know about when it comes to the aurora. Some of the most experienced scientists say that for every question that's answered, there are 10 more that need to be answered. It's a beautiful way to watch the sun and the earth and their magnetic connection. And it tells a beautiful scientific story.
All right, game time.
Okay, so that's the display of the different light colors caused by ionized species coming from the sun. So this is due to the different composition and temperature of the Earth's atmosphere. Now, because of this composition, the atmosphere can serve as a sink to different air pollutants or even pollutants. So that's why, because of the increased levels of human activities, in particular the combustion of coal, for example. So the combustion of coal, for example, has led to increased in the Earth's temperature in the past, let's say, 50 years. So scientists were able to measure this increase from analysis of ice core sheets that they have drilled in the North Pole. And from there, they have studied the levels or concentration of trapped gases, in particular carbon dioxide and water vapor. And then they have estimated that if warming continues, then this warming can go up and could cause increase in the Earth's average temperature. So the problem with this is that this is actually what we call as climate change. So the buildup of these greenhouse gases, in particular carbon dioxide and methane, into the troposphere causes what we call as climate change. So I mean to say that from the natural greenhouse effect, we have now an induced greenhouse effect caused by human activities, primarily from combustion of fossil fuels, including coal, crude oil, and then also from commercialized uh, livestock production that produces methane. So methane actually, even one molecule of methane is it has 4 times the capacity to warm up the Earth's temperature compared to one molecule of carbon dioxide. That's why even a small concentration or even half the concentration of methane in the Earth's troposphere as compared to the concentration, let's say, of carbon dioxide from human activities, then the potential of methane to warm up is 4 times compared to that of carbon dioxide. So for this reason, we have the condition known as global warming. So global warming has many effects. So this includes, let's say, the melting of glaciers. So recently, if you have heard on the news, there was a big chunk of iceberg that has slipped from its location in the North Pole. And if the Earth's temperature continues to rise up, then potentially this can melt the glaciers. So we all know that melting glaciers can, of course, cause rising sea levels. For example, this can accelerate urban flooding in many cities, even affect, let's say, ocean currents. It can change the natural direction or flow of ocean currents. And these changes can also accelerate the melting of glaciers in the Arctic regions. So a part of that, this can also cause decreased productivity, let's say in agriculture, in the oceans, can cause also loss of biodiversity, spread of tropical diseases to other countries that doesn't have them, and then other effects. So if you consider now these effects, these are actually interconnected to each other in what we call as climate change.
Population are driving up the Earth's temperature and fundamentally changing the world around us. The main cause is a phenomenon known as the greenhouse effect. Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sun's light in, but keep some of the heat from escaping, like the glass walls of a greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Human activities, like the burning of fossil fuels, have increased the amount of CO2 in the atmosphere by more than a third since the Industrial Revolution. The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's levels in hundreds of thousands of years. Climate change has consequences for our oceans, our weather, our food sources, and our health. Ice sheets, such as Greenland and Antarctica, are melting. The extra water that was once held in glaciers causes sea levels to rise and spills out of the oceans, flooding coastal regions. Warmer temperatures also make weather more extreme. This means not only more intense major storms, floods, and heavy snowfall, but also longer and more frequent droughts. These changes in weather pose challenges. Growing crops becomes more difficult. The areas where plants and animals can live shift, and water supplies are diminished. In addition to creating new agricultural challenges, climate change can directly affect people's physical health. In urban areas, the warmer atmosphere creates an environment that traps and increases the amount of smog. This is because smog contains ozone particles, which increase rapidly at higher temperatures. Exposure to higher levels of smog can cause health problems such as asthma, heart disease, and lung cancer. While the rapid rate of climate change is caused by humans, humans are also the ones who can combat it. If we work to replace fossil fuels with renewable energy sources like solar and wind, which don't produce greenhouse gas emissions, we might still be able to prevent some of the worst effects of climate change.
Okay, so to any problems, there are solutions. So one of the solution I described there is to switch back or cut back our dependence into fossil fuels and consider renewable forms of energy with cleaner technologies and no emissions of carbon dioxide and other greenhouse gases. And of course, improve energy efficiency. Then let's say reduce deforestation. And these are some of the prevention methods. So to deal with global warming, we have two kinds of methods of prevention. We say that we prevent further introduction or build-up of greenhouse gases in the Earth's troposphere. And then clean up means to say that we need to remove the excess amount of these greenhouse gases into these methods by assimilation, let's say, of carbon dioxide with plants. For example, planting trees. So this is sequestration method. So we need to remove excess carbon dioxide by planting more trees, and then we can also try to remove carbon dioxide from smokestacks of vehicle emissions and vehicle emissions. Then, of course, use animal feeds that reduce the amount of methane emissions. So currently, because of increasing demand of, let's say, beef, for example, there have been areas in the Amazon rainforest that have been cleared out because of cultivation of crops that have been used for feeds in the cattle industry. So we actually need to balance between the demand and the impact of all the activities we do in the environment. So part of the solution here is different countries have agreed to cut back their emissions 5.2% below the 1990 levels by 2012. This was done uh, in the agreement known as Kyoto Protocol. So most of the countries have agreed to cut back their carbon dioxide emissions level, and this protocol has been strengthened with amendments with the European Union in the Paris Treaty Climate Change Agreement. So again, this is a long-term goal to decrease carbon dioxide emissions and of course um, to keep the temperature, global average temperature, well below 2 degrees above the pre-industrial level. So if you talk about pre-industrialization, this is actually the time wherein few machines have already been invented, but after this revolution, the pre-industrial came the industrial revolution. That is where the massive extraction of fossil fuels, of course, to drive the growing economy in Europe, because that is in England that the birth of industrial revolution started, and then it migrated to other parts like in the United States of America for the invention of different engines like the steam engine, so which makes use of coal. So as an individual, we also have our own carbon footprint. So if you talk about carbon footprint, then how do we reduce our individual carbon dioxide emissions? So these are some of the methods that we can adapt, like use of energy efficient appliances and lights. So before we have these lights, the compact fluorescent bulbs or the CFL technology, but this time the CFLs are already, I would say, less efficient as compared to the LED lights. Then the carbon footprint also is, of course, caused by our food consumption. So if you try to consider this presentation about carbon footprint, how to reduce them, then we will learn that the type of food that we eat can also contribute to our carbon footprint.
You know you should probably reduce it, but what exactly is your carbon footprint? The carbon footprint refers to the total amount of greenhouse gases released into the Earth's atmosphere as a result of the activities of an individual or an organisation. Remember, greenhouse gases trap heat inside the atmosphere, and that's overheating the planet. So, if you want to work out your own carbon footprint, you need to know the amount of greenhouse gases, like carbon dioxide, you're responsible for creating. It's a difficult thing to measure precisely, and there are different definitions about how best to calculate it. But roughly speaking, there's the direct impact of using energy when we travel or to power our homes, and there's the indirect impact of the energy that's used to create all the things we use or consume. In the developed world in particular, transport is a big part of your carbon footprint. Cutting down on the use of petrol or diesel cars and taking fewer flights is one of the most effective ways of reducing it. The place you live also contributes to your personal footprint. It's important to make sure your home is heated or cooled efficiently and is well insulated. The more you can use sustainable energy like solar or wind power, the more you cut your emissions. The stuff you use at home also adds to the problem. All that plastic, metal and cardboard takes a lot of energy to produce and dispose of. So recycling can help reducing your carbon footprint, but not as much as how you travel or heat and cool your home. Then there's your diet. Above all, red meat makes your carbon footprint bigger because cows produce so much methane, another greenhouse gas, and huge numbers of trees are cut down to create pastures on which cattle can graze. In the developing world, polluting stoves are a real problem too, so it's important to try to replace them with more efficient methods of cooking. But overall, people in poorer countries produce far smaller amounts of greenhouse gases than people in richer countries do. So, if you look at just what a country produces, the average amount of carbon dioxide emissions per person in the United States is about 16.1 tonnes per year. In China, it's 7.1 tonnes, and in the UK, it's about 5.5 tonnes. But in the Democratic Republic of Congo, it's only 0.03 tonnes, while in Qatar, which has a really small population but produces so much oil and gas, it's 38.6 tonnes. Now, that's just production. It doesn't take account of all the other things we've talked about, how much you consume. But obviously, the more money you have, the more you tend to consume. So if people in richer countries really want to reduce their carbon footprint, they need to make huge changes in their lifestyles. It can be done, and new technologies to make things greener are coming on stream all the time. But it is a reminder that the declared aim in many countries of going carbon neutral by the middle of this century means a revolution in the way we live.
Okay, so as you have seen, the food that we eat is also produces some carbon emissions in terms of how the food is processed. So in general, plants, of course, that require more fuel in terms of its processing unless we consume them in its processed form. So even imported products and goods would have higher carbon footprints than locally produced products in the market. Okay. So the interaction also of the pollutants in the air is causing air pollution. So part of these pollutants are coming from two origins. We have natural sources and from uh, anthropogenic sources or human activities. So in terms of anthropogenic sources, it can either be point source. So if we talk about point source of pollutants, then these are the sources that we can easily pinpoint in terms of origin. So it can be stationary, it can be mobile, and these pollutants can interact with other gaseous components in the Earth's atmosphere. So let's say you have carbon dioxide, you have sulfur oxides, nitrogen oxides, and hydrocarbons. This can interact with water vapor, and then you form another kind of pollutants known as secondary pollutants. So for example, your Rain actually, it's the unpolluted rain is slightly acidic because of the presence of carbon dioxide that has been formed from reaction of carbon dioxide and water vapor. That is the slightly acidity of unpolluted rain around, let's say, 4.5 to 5.5 in terms of pH. But when gases as pollutant like nitrogen oxides, sulfur oxides would react further with water vapor, they can actually make the acidity of rain way below the normal pH levels. So these are the five the major air pollutants. We have oxides of carbon. Um, Special mention here is carbon monoxide because this one it's not a greenhouse gas but is highly toxic in the sense that this can compete with the oxygen molecules in our blood vessels. So if you have inhaled, for example, these gases like carbon monoxide, since this one is odorless, this one is tasteless gas, for example, this is produced from incomplete combustion of engines that runs on fossil fuels. Let's say that runs on diesel, for example, or gasoline. There are incomplete combustion byproducts, and one of them is carbon monoxide. So carbon monoxide can compete with oxygen in terms of binding. So our blood actually contains hemoglobin, and it is the role of hemoglobin to carry oxygen to the different cells of our body. And since of the similar chemical and similar properties of carbon monoxide and oxygen, then there is a higher possibility that this can be transported in our bloodstream. It can cause poisoning. So aside from oxides of carbon, we have nitrogen oxides and nitric acid. So nitrogen oxide, it's a primary pollutant. These are formed from combustion of fossil fuels, including coal, from smelting of ores, for example, which includes your sulfur oxides. And this one can also be generated from volcanic eruption. So any volcanic activities that would emit tons of SO2 can potentially make the acidity of the rain fall from the normal range. Then, of course, you have suspended particulate matter. This one are very fine particles with a size of less than 10 micrometers. We call them as particulate matter 10. So this type of particles can be inhaled. So the danger of suspended particulate matter is that the smaller is the size, then uh, the more likely they can be incorporated in our respiratory system, and therefore it can cause a respiratory conditions. So they can either accelerate existing respiratory conditions. So that's why we need to wear masks that are specifically designed to prevent inhalation of suspended particulate matter because ordinary masks cannot filter them out. So aside from this, we have ozone. So earlier we learned that ozone is beneficial in the stratosphere because it filters the harmful UV radiation. But when it is in the troposphere, it is considered to be a pollutant because this one is a byproduct of uh, primary pollutants interacting with other kinds of pollutants, and they form into ozone, which is one component of a photochemical smog. So photochemical smog are usually very evident in urban areas, which includes your volatile organic compounds, solvents that can form vapors. They can easily vaporize, and they can be mixed with other pollutants in the air that can form into photochemical smog. So it's called as photochemical because this one is catalyzed by the action of sunlight. So the term photo coming from, of course, photons of energy or sunlight. Then, of course, heat from volatile organic compounds, from nitrogen oxides. And you would observe that this one is a similar or familiar scenario in urban areas. There is a brownish coating, or we call as haze, just above the atmosphere. This one is caused by photochemical smog. Now, air pollutants have various effects. So this can include also effects to our health, for example, and other types of effects.
Serious health and environmental threats. But what causes air pollution and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens. But most air pollution results from human activities such as energy use and agriculture. There are different types of human made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change, and climate change creates higher temperatures. In turn, higher temperatures intensify some types of air pollution. For example, climate change increases smog because it forms in the presence of high heat and increased levels of ultraviolet radiation. More frequent extreme weather, such as flooding, contributes to damp conditions and therefore to a rise in mold. Warmer weather also leads to longer pollen seasons and therefore more pollen production. Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress. Another category of air pollution is toxic pollutants. These are chemicals such as mercury, lead, dioxins, and benzene that are released during gas or coal combustion, waste incineration, or burning of gasoline. In addition to adverse environmental effects, toxic air pollution can cause serious health problems such as cancer, reproductive complications, and birth defects. While air pollution has many consequences for our planet, there are solutions. We can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.
Okay, so again, to any existing problems, there is a solution, and majority of the solutions presented and covered are actually we need to cut back dependence on fossil fuels, coal, including crude oil, and switch to renewable forms of energy. So apart from the interaction of the pollutants in the air from primary to form secondary pollutants is the condition known as acid rain. So acid rain is actually produced from the interaction of nitrogen oxides and sulfur oxides with water, and they can cause acid deposition. So acid deposition can be in the form of rainfall. We call that wet acid deposition. There is also dry type of acid deposition, and of course, this one can of course affect the natural pH conditions of, let's say, vegetations and crops, including the soil. If we try to look at the the map in the United States where regions are vulnerable to acid deposition is on this part of the United States, the West Coast region. And then global map would show us that you have here in the West Coast of the United States, this part of Europe, and this part of China. So a highly industrialized and urbanized area, for example, because of increased number of factories that process coal, for example, or that releases nitrogen oxides, sulfur oxides, can of course increase the incidence of acid deposition. So acid deposition has many effects. This includes leaching of nutrients in the soil, for example. So this can release toxic metal ions in the soil, leaching of nutrients, which can cause, let's say, reduced photosynthesis and growth of trees. Then eventually, because leaching out of nutrients into the nearby bodies of water, including lakes and rivers, including the groundwater, can deplete the nutrients in the soil. So this can cause eventually the trees to die off. So this is very evident in countries, in the Western countries. They have deciduous type of forest where pine trees can grow, and there have been decline in the population of trees caused by too much acidity of the soil, for example. Even agricultural areas have been affected. That's why some farming methods would employ application of calcium carbonate. If you have observed some farmers, they put this calcium carbonate in the soil to either balance the pH of the soil or reduce acidity of the soil, because calcium carbonate is an alkaline, can react with acid and neutralize that with the acid. So part of the solution to acid deposition, again, it's removing, let's say, sulfur oxides, nitrogen oxides, and then as much as possible, burn low sulfur coal. So coal actually has different type. So there is what we call as lignite, there is anthracite, there is bituminous type of coal, and each of these coal has various degree of sulfur content. But apart from this, we need to consider also the price. I think for coal type with lesser sulfur content, it's more expensive than the usual type of coal. So we actually get our coal from either from China and other countries that supply coal. So we have here in our region, we have industries that generate electricity from combustion of coal. So you're familiar with Stayag, for example, so they actually is one of coal-fired power plants. Then of course, clean up. We add lime to lakes, for example, to neutralize acidity, and even, let's say, fertilizers. But fertilizers, if applied in excessive amount, can also cause other problems in our bodies of water. So if there is pollutants outside our home, there are also pollutants inside our home. We call them as indoor pollutants. So this includes chemicals like tobacco smoke, formaldehyde, radioactive gas, radon, isotope 222, and then ultrafine particles. So if we examine our homes, try to check your house if you house some of these chemicals, let's say cleaning agents, mga solvents, even furnitures, for example, they can contain, let's say, styrene. There are, let's say, in carpets, for example, some byproducts of their manufacturing. So especially no asbestos. So asbestos actually it's for homes that have been built before, like in the 1940s, 50s, before 1980s. They have this roofing material that has coated with asbestos. But I think nowadays, you only seldom see houses that have asbestos on it, because this one actually is one of a carcinogen. So before, they have been used, but in any chemicals, they're considered safe unless proven guilty by any other study. So that's why we have these chemicals here. So if you have some of them, household cleaners, try to store them on a separate location. let's say outside the kitchen, or let's say kung may separate area dito yung ipambutang ng mga let's say na may mga paint, na may thinner for example, mga cleaning agents. So that has to be separated. Even insecticides for, let's say, mosquito repellent, especially those which are uh, kanabitong artificial that contains chemicals. So we have natural insect repellent, those with formulations of citronella. So try to check if you can see them in the supermarkets with citronella formulation. So this is an effective insect repellent. Then also including tobacco smoke. So smoking actually cigarettes, especially secondhand smoke, contains much more chemicals than the first-hand smoke, which the smoker would inhale. So compared to non-smokers, secondary hand smoke would contain more hazardous air pollutants and chemicals than the smoker itself. So mga benzoypyrene, these are coming from incomplete combustion. So if you have dirty kitchen, for example, so just make sure there is proper ventilation to prevent any either byproducts of incomplete combustion. Then of course, including house mites, mga dust mites in our bedsheet, for example, pillowcases, for example, mga upholstery. So it can house actually mga dust mites. It can cause allergy, for example. So the U.S. has data on the deaths caused by air pollution. So again, on the West Coast, it's more prominent because of a highly industrialized area. So these are some of the solutions. So again, renewable energies. So it's better to prevent than to clean up, but these two methods can be coupled to each other to reduce either the buildup of these pollutants and then, of course, indoor air pollution. So these are some methods like have proper ventilation, and then, of course, we can use plants. So there are plants that can actually remove some of these toxic pollutants inside our homes. So try to check what are these plants that can be indoor plants, which are locally available, which can of course sequester some of harmful pollutants inside our homes, and of course generate oxygen. So what you can do is, of course, these are some of the methods. I think ang radon here is not that measured inside our homes because namin mga radon detectors. Actually, ang uban nga mga housing facilities, especially in mga Western countries, they have a radon detector which can, of course, detect concentrations of radon. Okay, do you have questions? So we'll just end here with air pollution. Then by next meeting, we'll discuss on water pollution and solid waste pollution. Questions so far? Never take questions. So if there are no questions, then we'll just end at this point and then we'll continue next week. Okay, so I'll just send. So the remaining topics for next week would include water pollution, solid waste pollution, and then what else? Green chemistry and application of green chemistry to, let's say, energy. Since I think we're only up to Tuesday next week for the classes because I think 20 is already Christmas, start of the Christmas vacation. When we return in January, we only barely have 2 weeks, I think, before the final exam. So I would only allot that weeks either for pre-final exam or final exam in the lab, and then of course a focused group discussion in preparation for the final exams on the 15th of January to 20th that week. Okay, so I'll see you by Monday next week. Monday or Tuesday? Basta next week. Yes, Monday. So we still have one meeting left Monday. Okay? So ako lang isend later ang copy sa ako and presentation. So that will be all for today. Thank you for joining. For those, by the way, who have not yet submitted their calculation solutions,